Hello once again, and let's start with a weekly analysis of the coronavirus. So first of all, just to remind that the infection curve has a given shape in the beginning because of the natural characteristics of the virus, and well, regardless of what we take in the very short term, the curve will maintain its surface underneath. So we'll have a defined number of infected people either here or we can smoothen and have it in a longer period or have a spike in the future. But this is that comes from the virus dynamics. So we have to face this is the fact, and then we have to maybe mitigate this, or we have to avoid it in another way. We'll see later on. So the fatalities that we have to experience and the dynamics of such a disease are that it mostly affects senior people, and that factor crossed with the population pyramid of all the countries, which is open and available on the internet. So you can start drafting your very own numbers. So luckily, according to the last fatality rates from the disease, we can estimate that the annual fatalities for 2020 will be lower than initially expected. So let's say at about 10%. So all countries, of course, will have this 10% overhead or more within a period of a very few weeks or months. So that will overload the system. But so far, it is not as severe as it was initially expected, luckily. So in order to assess this, we started reconstructing the curve. So on one hand, we had the initial infection curve in blue, and then we had the fatalities and the recovered people. So we can see that roughly the curves, when you reconstruct it in the US, for instance, they match. So it's likely to be reliable data and trustworthy data. In Europe, in Germany and France, it looks that both curves or the three curves are similar when we have the original infection curve, and then when we overlap with the death rate, and when we overlap it with the recovery rate. So all of them, they match. In Italy, however, we can appreciate a gap between the recovered and the synthetic recovered and the infection. So there is a gap between both curves. So maybe some people are not admitted to the hospital and they are discharged or released early on, and we cannot count, and they are not accounted in the system. So, however, the dead people really, or the fatalities, are really matching the infection profile. So maybe this is at a different scale, but it is reliable that the infections are counted in a significant proportion of the real population. In South Korea, however, the original curve was matching roughly, but then we appreciate that there is the same gap in Italy. So the recovered and the infected, they are not matching at all. And the fatalities against the infection curve, the declared in the population of infected population do not match at all. This may be induced because there is a gap between both curves, as it happened in Italy, and we have to further investigate on what's going on with that. According to the fatality curve, this should indicate that they have flattened the curve. The curve is not changing its slope anymore. So, and they are having almost the same the same amount of fatalities per day. So they have somewhat controlled this. So they have what we said was flattening the curve, the infection curve, but they are not yet mastering in order to decrease the effectivity, as we saw in China, for instance. In Spain, we can see as in Europe, so all the three curves match, but the parameters that will be later on reconstructed are from our concern. And the world has have the same curve, the same behavior. So all the three curves are consistent each other. So it's likely to happen this. What the only difference that may exist is the real scale factor of this. So maybe there is a way higher population infected that is not attending to the and they are not accounted. So what we see roughly is that the overwhelmed healthcare system is driving this weird shape of curve. Let's say that the fatality rate, it tells us that the fatality rate is way higher in countries where the hospital, the people stay in the hospital for a shorter period. And then people which are standing for longer, those countries have a way lower fatality rate. So how this can be if the virus is the same and we are all humans? Our guess is that the overwhelmed systems, once they are saturated, you start discarding a lot of people which could stay for longer in the hospital. And those which have enough capacity to absorb all those, they are really dealing with a fatality rate which is way closer to the real one and is more reliable. So here we can see the real effects of having the start working on the very early on beginning of the curve when the slope starts increasing, or once you have already disaster coming in, you cannot see the wave of the death toll that is coming to you. So the figures displayed in another plot with the same figures. It's not a consequence, so it doesn't mean that if you had those patients staying for longer, the case fatality ratio will be lower. It just means that if you could have admitted more people into your system, the case fatality ratio will be closer to the real case fatality ratio in their country. It's just in this way. So, and the time to die is about 7 days roughly. So once people attend to the hospital, the ones which are on the course to die, the average time will be about 7 days, almost everywhere. So this is the clinical course. So people get exposed here, infected for 2 days with no symptoms, and they are not infectious at all. Then they spend a few days of infection with displaying mild symptoms or severe symptoms in the more longer term. And here it's when it's most dangerous, because people are doing business as usual for 2 or 3 days, and they do not feel even wrong. They do not feel bad. And then here, after these days, when they have severe symptoms, they go to the hospital, and severe cases attend to the ICU just to die, and some others spend from 10 to 20 days, and they are discharged from here to there, depending on the country, if they have more space, more room. What we have to be prepared is, because this is an RNA, it's fast-changing virus, and we can see the different Cs that we have in our different areas. This is mostly European, but some also are also found in the US, and here we have the original ones. But it's changing dramatically, and here we can see that there are strong and heavy mutations, not only here, but also in the other parts of the world. So we cannot say that one variant is changing faster than any other. So it's changing all around the globe. And finally, just to wrap up, the slope in the curve will remain constant whatever we do, because we are not changing the dynamics. The infection curve, however, can be modified. The slope can be modified. Vaccination or drug medication may disrupt the contagion dynamics and will really dramatically flatten or break the curve in a drastically way. So that's what we have to look after. And of course, if there is any country which has not experienced a steep curve, there is a strong risk of rebounds when the lockdown gets removed. Of course, the research lines to get more information about the mammals infection vectors and the species, the pets, and so how we can disinfect and work in a different manner, because this will, maybe we need to change our habits in the future, not just for this infection, but for the coming ones, which are we have to get ready for this. And of course, we need to develop a faster response systems in order to mitigate sooner the consequences. As we can see, we have seen, acting with a delay is not providing any advantage on this. So that's all. Thank you very much for watching. I wish it was useful. For any comments, just email. Thanks.